Good afternoon, my beloved people out there. You are welcome once again to our online teaching series. Today we are going to take a look at practice question number 9, a question in physics. Now here we have a problem on the board, motion of connected bodies. Now look at the word. They said from the diagram above, derive an expression for the acceleration of the system. Take a look at the system. Well, we should derive an expression for the acceleration of that system. Follow me as we do that. To derive an expression for that system, let's first of all bring down the system. This is the system. And we'll have a body of mass here, tag mass M1, attached by a constant string to yet another body of mass, tagged here as mass M2. So here, if you take a look at this, you don't need a soothsayer to tell you the motion of these bodies. Here we have T2 tension and here we have T1 tension, T1. Now take a look at it. It should be recalled that these two bodies of masses are under the effect of gravity. That is to say, if there is a cut here, this body of mass begins to fall down, it will fall down. So it means it is under the influence of gravity. So the weight of this object, W, is acting vertically downward. And remember, weight of an object, we're talking about mass M2, so we're talking about weight 2, W2. The weight will be equal to the mass of the body times acceleration due to gravity, so M2G. Consider this mass also. The weight of this object is acting downward, and the weight W1 will be equal to M1G. If you take a look at the both of them, G is constant, acceleration due to gravity. And this is what we want to see. We want to see the acceleration of this system. Now, if you take a look at this system, look at it. The motion of M1 is towards this way. The motion of M2 is this way. Now, it means that here, if the acceleration is upward, here is downward. So, we want to see the acceleration. How do we get the acceleration of this system? Follow me. Now, take a look at this. Let's consider case 1. In case 1, we are looking at mass 1. So considering mass 1, the motion is upward. It means that the tension T1 minus greater than the weight minus the weight W1 will be equal to mass times acceleration. Remember, tension is a weight, is a force, weight is a force. So from Newton's second law, force is equal to mass times acceleration. So this is a force, this is a force. So from here now, if you make the tension T1 the subject, it will be equal to, what we have here is that we have M1A plus W1. And remember, W1 is the same as M1G. So we can remove W1 here and put M1G. Let's take this as an equation 1. Now let's consider the second mass, case 2. Case 2 now, we are considering M2. Considering M2 here, look at the body is accelerating downward. It means that the weight minus the tension will be equal to mass times acceleration. So we'll have it that W2, which is pulling down T2. So W2 minus T2 will be equal to M2A. If we make T2 the subject of the formula, our T2 now will be equal to W2 minus M2A. And remember, our W2 is M2G. So I remove this and I put M2G. So this now is our equation number 2. But we should recall that a singular string is used to attach the both body of masses. And know that as long as we have a constant string we have, then it means that constant string, then comma T1 will be equal to T2. So if T1 is equal to T2, in our equation 1, we have that T1 is equal to M1A plus M1G. And now we're saying that T1 is equal to T2. So it means that M1A plus M1G in equation 1 should be equal to T2, which is M2G minus M2A. So that will be equal to m2g minus m2a. At this point now we take like terms. If m2a comes this way, it becomes m1a plus m2a equal to, I have m2g, when m1g come over to this side, become minus m1g. A is common, so a into m1 plus m2 will be equal to, here g is common, g into m2 minus m1. This is our area of emphasis, the acceleration. So therefore, the acceleration of the system will be equal to g into the bigger mass m2 minus the smaller mass m1 divided by the summation of the masses m1 plus m2. These give the expression for the acceleration of this system. Hope it got to you in the right state of mind. Sit down, do more research with your textbook, and I believe you will get more than what you have seen here. Take advantage of this video. Please like and share this video until we see in our next series. Thank you and bye for now.